Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So in this specific discussion, we're going to look at the concept of classes. Now, in my introductory videos on various terms, we're going to come across in statistics, especially on the frequency or cumulative frequency distribution table. We're going to come across this specific column referred to as a class. Now, for us to organize data and try to cater for every aspect of each individual set of data, we're going to organize these specific values in terms of a class. And these are going to be given using a specific groups of data or a range of data. Now, in this case, for us to, of course, successively have this specific kind of data, of course, catered for, we're going to organize these ones in various sets of classes, which are mentioned, of course, given in these specific sets. Now, there are specific rules or guidelines which are going to be adhered to in order for us to have this particular set of classes given, in a sense that, of course, adhering to those specific rules, then therefore are going to give us a convenient way of trying to represent this particular set of data. Now, I'm going to look at these specific rules. Now, I've given this lower set of data, which of course is going to assist us achieve that one. Now, in this case, I have a set of data which basically consists of these values, and of course I'm going to look at these specific values. Now, for organizing these specific values in terms of a table and a specific range of numbers between 6, 11, which is going to give us what we refer to as a range, and I'm going to mention that one later in case we come across them. But basically, as I mentioned, the concept of a class as basically a specific grouped set of numbers which is going to give a range of data, and this is going to be having a specific interval which I've referred to as a range. So in this case, this constituted the lower and the upper class, of course, limits, which are mentioned under the various definitions. So in this case, the specific rules which have adhered to have to be adhered to, of course, in a sense, try to categorize the numbers under which the classes are going to be, of course, given. So in this case, they should range between 5 and 20 classes in that specific order. So which means basically we're going to adhere to these specific rules by trying to confine our number of classes between 5 and 20 in that specific case for convenience. So in this case, given this distribution consisting of 1, 2, 3, 4, 5, 6 classes. So it's within this specific range, and therefore that's going to form one of the basic rules which, or the guidelines which we have to adhere to in order to construct classes. So the second one, of course, is going to be given in a sense that these classes have to be mutually exclusive, and of course, in a sense, therefore, this aspect of mutual exclusiveness implies that every set of data has got to be represented, and of course this specific set of data in classes are not going to fall into two categories. So in this case, it implies that if we have 6 to 11, this first class gets us for the range of values between 6 and 11, and none of these specific values is going to be given in a second class of 12 to 17. So this entails the aspect of mutual exclusivity in a sense that no single value can be given in two different classes, and that of course is another rule apart from the number of classes which we have to adhere to. So the next one is that these specific classes have got to be inclusive. Now, inclusivity implies that each of these specific values which we have listed for this particular distribution has to be catered for in this particular case, and therefore all the data values must be included in this specific range of classes which we have mentioned. And that's one of the third, or rather, well, that's a third rule that we have to adhere to in order for us to construct this specific kind of classes. And of course, we're going to see that there should be no gaps in the frequency distribution. Now, to mention the concept of gaps, especially between the difference between this specific, of course, upper boundary and the lower boundary or the lower limit of this subsequent class, which we had given in terms of a u, which was a unit of measurement. So in this case, for classes, they must be continuous in a sense that there's not going to be any gap being given in the frequency distribution. And of course, the classes are going to be equal. They're going to be equal in width, Now the width of the class that I mentioned basically is the difference between these two. Now in our next discussion, I'm going to give a specific formula for us to find the width of a class. But from this we can look at it basically by finding the difference between the lower class limit and the upper class limit. So in this case, this is going to give us a specific value. And of course, we're going to see that there's a way in which we are going to define this specific class width given in terms of W. But in an essence, before you define that specific formula, we're going to see that this specific set of values must give an equal width for each of these set of classes. So basically, which implies that the width for this one must be equal to this one going in that specific order. So that's basically is another rule which we have to adhere to. And of course, we're going to see some sets of data, especially which we are given in terms of some data like the age of an individual or a particular population can be given in terms of above or below that specific kind of a class. So we're going to see some distributions being given perhaps 65 years and above, or perhaps 20 years and below given in that specific order. So that's going to form a set of data. But in case we come across that specific range of data which is given as above or below, then therefore I'm going to elaborate on that specific difference. So assume that we have understood some of the rules which we have to adhere to, especially in constructing these classes, whereby in summary form I've mentioned that they have to range between 5 and 20. Now in our case we have 1, 2, 3, 4, 5, 6 classes. And then they have to be mutually exclusive in a sense that all the data must be, or rather in a sense that this specific no data or no element of this specific distribution is going to appear in two classes, and that's the concept of a mutual exclusivity. And then we're going to look at the concept of inclusive, that all the set of course, this particular representation have to appear in the table, and that consists of the concept of inclusivity. Of course, whereby all the data must be, of course, catered for in this particular distribution. And then I talked about the class width, which has to be the same across the classes. And then lastly, I've talked about the concept of having a set of data which is going to be either below or above, depending on what kind of data we are dealing with. So that is it for now, guys. Kindly check our description boxes for various links of other videos which we are going to do under the concept of statistics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.